Algebra 2, Chapter 13, Section 3. Putting a rational function in quotient form. So, the main thing we're going to be talking about in this video is how to put an arbitrary rational function into quotient form. And we're going to do this using a technique called polynomial long division. Polynomial long division. Okay, and it sounds a lot like regular long division, and it is, except we're using polynomials. So let's go ahead and dive right into this. I think this is familiar enough from people that know long division that doesn't need a whole lot of explanation. So, to divide x squared plus x plus 1 into 3x to the fourth minus x cubed plus x squared plus 2x plus 1, we write our denominator down 3x to the fourth minus x cubed plus x squared plus 2x plus 1. And then we're going to put the division house or division bar over our denominator. Sorry, our numerator. I said the wrong thing to begin with. This is the top of our fraction. Okay, so we're going to take this and we're going to divide x squared plus x plus 1 into it. Okay, that's what we're doing. Okay, so we write that denominator on the left, the numerator goes inside. And now, just like with long division, we think, what do I need to multiply x squared by to get 3x to the fourth? The answer would be 3x squared to get x to the fourth. Okay, we write the 3x squared not on top of x to the fourth, but we keep the powers lined up. So we'll write 3x squared is the first part of our answer here. And then we will multiply 3x squared by this whole polynomial and write it under here and subtract, just like we do in long division. So 3x squared times x squared is 3x to the fourth. 3x squared times x is 3x cubed. 3x squared times 1 is 3x squared. And then we subtract these polynomials to get the next step. So when we subtract, we need to be very careful to erase this last subtraction bar here. We need to subtract by the negative of this whole thing. Okay, so we're subtracting everywhere. This is easy to make a mistake with. So 3x to the fourth minus 3x to the fourth is 0. We don't need to write 0 down. Minus x cubed minus 3x cubed would be minus 4x cubed. X squared minus 3x squared is minus 2x squared. Okay, and then we can carry this stuff down as we go. Okay, we don't have to write that down. We can save space by not pulling things down. So what do we need to multiply x squared by to get minus 4x cubed? We need to multiply by minus 4x. So minus 4x times x squared gives us minus 4x cubed. Minus 4x minus x gives us minus 4x squared. Minus 4x times 1 minus 4x. Okay, subtracting everything. Okay, so minus 4x cubed minus 4x cubed, of course, is 0. Minus 2x squared, basically plus 4x squared, is going to give us plus 2x squared. And we have 2x plus 4x gives us 6x. And now we have the last step, which is, what do we multiply x squared by to get 2x squared would be plus 2. 2 times x squared is 2x squared. 2 times x plus 2x, 2 times 1 plus 2, and subtracting, we get 6 minus 2x is 4x, 1 minus 2 is minus 1. This is our remainder here at the bottom after we've gotten the final term in our result, in our quotient. Okay, so now we can write, but the problem doesn't ask us to do this. The answer would be 3x squared minus 4x plus 2 remainder at 4x minus 1. That's the answer to the division. We could use the result to write the original polynomial in quotient form. 3x to the fourth minus x cubed plus x squared plus 2x plus 1 equals equals the result 3x squared minus 4x plus 2 times we're running out of space here. So let's hold this thought. Let's bring this stuff down here. Okay, so we have 3x to the fourth minus x cubed plus x squared plus 2x plus 1 equals, and then we're going to use the quotient form where we multiply the result 3x squared minus 4x, or the quotient, plus 2 times the original denominator or divisor, which would be x squared plus x plus 1 plus the remainder, 4x minus 1. And so we can distribute this out and add this 4x minus 1, and we'll get back to this original polynomial. And of course, another way of writing the quotient form is to write it like this: 3x to the fourth, this was in the last set of slides we did, minus x cubed plus x squared plus 2x plus 1 divided by x squared plus x squared plus x plus 1. I'm going to erase part of our work here so we have space. Equals, and the result, which was 3x squared minus 4x plus 2 plus the remainder divided by the divisor, or the original denominator, sorry. 4x minus 1 over x squared plus x plus 1. Okay, so there's our quotient and our remainder. So we can, when we're writing in quotient form, we can pick either of those forms. This is more writing the second form, because you have to write the denominator twice. But if we put it in this form, where we have the original polynomial equals the quotient times the original divisor plus the remainder, that form is more less writing, so we'll use that form. So write this division in quotient form. But to do that, we need to do polynomial long division again. So let's practice doing it again. X cubed minus 2x plus 1. Now here we're missing the x squared, and that's important. So we will often, inside the division house here, inside the bar, write this out as plus 0x squared, so we don't lose track of the x squared position. Similar to how you have a 0 in a number. If we had 1001, we write the zeros in between the ones. So we're going to write that inside here so we don't lose track of it. So then we need to figure out, what do we multiply x by to get x cubed? We have to multiply by 1x squared. So x squared times x is x cubed, and x squared times minus 2 is minus 2x squared. Minus 2x squared. And now doing the subtraction, don't forget we're subtracting each of these things. So we have x cubed minus x cubed is 0. Nothing minus negative is going to be plus 2x squared. Okay, and then you carry this stuff down, but you don't have to write that to save time. So what times x gives us 2x squared? That would be plus 2x. gives us 2x squared, and then 2x times minus 2 is minus 4x. Subtracting, we get 0. Minus 2x minus minus 4 would be minus 2 plus 4, which is 2. And then what do we multiply by x to get 2x? Well, just 2. 2 times x is 2x. 2 times minus 2 is minus 4. Subtracting, 0. 1 minus minus 4 is 5. So we have remainder 5. So to put it in quotient form, we could either leave this here. So let's again do an example of both ways. So we could say this division equals x squared plus 2x plus 2 plus 5 over x minus 2. That's our remainder. Or we could write it this way: x cubed minus 2x plus 1 equals x squared plus 2x plus 2 times x minus 2 plus 5. Another problem, put this in quotient form. So another division. We need to divide x squared, and again it's helpful to write these zeros out so we don't lose track of the places. Plus 1 divided by 2x, we're going to divide 2x cubed plus 3x squared by x squared plus 1. 2x cubed plus 3x squared plus 0x plus 0. Okay, so we have to multiply x squared by 2x to get to 2x cubed. So we'll have 2x cubed. 2x times 0x is 0. 2x times 1 is 2x. Okay, subtracting all this, we'll get 2x cubed minus 2x cubed is 0. 3x squared minus 0 is 3x squared. So you see why we want to keep the zeros in here to help us line everything up right. 0 minus negative 2 is minus 2x. So now we think, what do we multiply x squared by to get 3x squared? Well, that would be 3. We get 3x squared minus 0 plus 3. Subtracting, this is 0, minus 2 minus 0 is minus 2x. And then 0 minus positive 3 is negative 3. So that's our remainder. So we could write this as 2x cubed plus 3x squared equals 2x plus 3, our quotient, times the original denominator, x squared plus 1, plus the remainder, which is going to be minus 2x minus 3. Write this one in quotient form. So we're going to take x cubed minus 1 and divide it into x squared plus 1. But let's remember, we want to keep track of the zeros in the middle to keep things lined up right. So let's make this bigger, and we'll do the same thing in the denominator spot, x squared plus 0x plus 1. So we have to multiply x cubed by x to get to multiply x squared by x to get x cubed. So we have x in the answer. X times x squared is x cubed. I moved it over so it lines up with x inside the division house. So we have x times 0x is 0. X times 1 is x. Subtracting. And we get x cubed minus x cubed is 0. 0x squared minus 0x squared is 0. 0x minus x is minus x. Okay, because 0 minus 1 is negative 1. And of course we carry this down. I'm just going to keep the bar out of the way to remember to carry that down. You're welcome to carry this down yourself. It's just more writing, so I generally don't bother. Now we get to multiply. What can we multiply x squared by to get x? There's no polynomial we can multiply. We'd have to multiply by x to the negative first. So this is it. Okay, so this doesn't make much sense. Maybe we made a mistake. X times, so there's x cubed, okay, and then multiply, so if, oh no, this doesn't make sense. So we have x is our quotient, and negative x is our remainder, but it goes over x squared plus 1. So that I was confused by the fact that our remainder, if we added it to the quotient, would be 0, but the quotient doesn't have the divisor under it. But the minus x does. It's the remainder. So if we write this as quotient form, it's x cubed minus 1 equals x times x squared plus 1 minus x. Okay? Determine the equation of the slant asymptote of this rational function. Well, if we remember, if we write it in quotient form, the non-remainder part will tell us the long-run behavior, which will be the asymptotic behavior. So we need to do, again, polynomial long division. X squared plus 2x minus 8 into 2x cubed plus 6x squared minus 26x minus 30. So we have to multiply by 2x to get 2x cubed. When multiplied by x squared, that would go over the x. So 2x cubed, 2x times 2x is 4x squared, minus 16x, subtracting. And I always put these parentheses to remind me that it's subtracting, each entry is subtracted. So 2x cubed minus 2x cubed is 0, 6x squared minus 4x squared is 2x squared, minus 26x minus 16x would be minus 26x plus 10x, which is minus 10, would be minus 26x plus 16x, which is minus 10x. And of course the minus 30. So then we have, what do we multiply x squared by to get 2x squared? But well, just by 2. So 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times minus 8 is minus 16. Subtracting, we get 0. Minus 10 minus 4 is minus 14x. Minus 30 plus 16 would be minus 14. So we can write this in quotient form. Let's do it the other way this time. It would be 2x plus 2 plus the remainder, minus 14x minus 14 over the denominator x squared plus 2x minus 8. Okay, this is a little trickier. Given that p of x, which we don't know, divided by x squared minus 5x plus 6 equals x plus 2, find what p of x over x minus 2 must be. So there's a little bit of a logic game here. I think it'll help us a lot if we factor the numerator. Sorry, the denominator. I keep getting these words mixed up. I'm very sorry. Factor the denominator. So x squared minus 5x plus 6 equals what multiplies to 6, well 2 and 3 do, and adds to minus 5, minus 2, and minus 3. Okay, so then we can write this first part as p of x over x minus 2, x minus 3 equals x plus 2. Well, we're almost looking like what we need to find. If we just multiply both sides by x minus 3, I'll have an expression, p of x over x minus 2 so p of x over x minus 2 equals, and we don't necessarily have to multiply this out, x minus 3 times x plus 2. Okay, so that's the answer. It's a little tricky, but that's how we do this kind of problem. Given that all this is true with remainder of 1, So x to the fourth plus x plus 1 divided by x plus 1 is equal to x cubed minus x squared plus x with remainder 1. Find x to the fourth plus x plus 3 over x plus 1. Okay, so looking at what we need to find, it's very similar to what we started with, but instead of plus 1, we have plus 3. So if we remember, we take this out, and remember what remainder 1 means, it means we add 1 over x plus 1. Okay. If we take this fraction, x to the fourth plus x plus 3 divided by x plus 1, and we split the 3 up so that we have exactly what we have here, x to the fourth plus x plus 1, and then if we had plus, and I'm writing it this way on purpose, plus 2, so plus 1 plus 2, okay, is 3. So all I did was split up 3 to being 1 plus 2, and then spread this out so I have space to write this denominator, and split the fraction up, because we can always split a fraction up, keeping the denominator the same, and putting the numerator, just the pieces on top, and adding together, because you add the tops when you add fractions that have the same denominators. So this is the same thing. These are equivalent. Okay, and we know x to the fourth plus x plus 1 over x plus 1 equals this, plus that. Okay, so x cubed minus x squared plus x plus 1 over x plus 1 plus 2 over x plus 1. And then we add the 1 and the 2 here, we have this is equals 3. X cubed minus x squared plus x equals 3, not equals, plus 3 over x plus 1. Now we could say that this equals x cubed minus x squared plus x with remainder equal 3. Just like we had here with remainder equal 1, we can do the same thing in the answer. Okay. Now let's talk a little bit about a thing called the remainder theorem. So for any polynomial, p of x, and any number, constant number a, the polynomial of x would equal x minus a times the quotient q of x plus p of a. Okay, meaning put in the constant a into the polynomial, that's what you get for this remainder. Where q of x is the quotient that we find by dividing the first polynomial by x minus a. So this is just putting this division by x minus a into quotient form and realizing the constant that we add is just the polynomial function times a. This is known as the remainder theorem, and this is important because if the remainder is 0, that tells us that x minus a is a factor of the polynomial. In other words, zeros are factors, like we've already talked about. But this gives us a way of using polynomial long division to test whether something is a factor. So let's try that. Okay. Is x minus 4 a factor of this big polynomial? So going back to the remainder theorem, we need to divide x minus 4, divide this polynomial by x minus 4. And if the result is such that the remainder is 0, then it is a factor, and if the remainder is not 0, it is not a factor. So let's try this. And this is actually similar to how you would test if a number is a factor of another number. You could divide, and if the remainder is 0, you know it's a factor. So you can use what we know about numbers to help us learn about polynomials. So writing the division problem out, 5x cubed minus 13x squared minus 30x plus 8. What do we multiply x by to get 5x cubed? Well, that would be 5x squared. So write that over the x squared. We get 5x cubed minus 20x squared. Subtracting 0, and then minus 13 plus 20 is 7x squared. What do we multiply x to get 7x squared? 7x. That gives us 7x squared minus 28x. Subtracting, we get 0. Minus 30 minus 28 would be plus 28. Minus 30 plus 28 would be minus 2x. And then we want to multiply x by minus 2 to get minus 2x, which would give us minus 2x minus 2 times minus 4 plus 8. Subtracting, and we get minus 2x minus minus 2x is 0x. 8 minus 8 is 0. The remainder is 0, so the answer is yes. Yes, the remainder is 0. So we found that basically 4 is a 0 of our polynomial. So we put 4 in here, we would get 0 out. But we didn't do it by trying to put 4 in. We did it by doing this division and seeing what the remainder was. Okay, so that was a long way of doing it. Okay, and so this is just to show how you do it with the long division, but we didn't have to do that. We could have used the remainder theorem. The remainder theorem tells us that all we have to do is see, is a, this p of a, this number 0? Okay, so a faster way to do this problem is to use the remainder theorem and say, what's p of 4? Okay, so is p of 4 0, basically? So we just need to plug 4 into our polynomial and see, do we get out 0? Okay, so getting a calculator out. We just need to find p of 4. Okay, so 5 times 4 cubed minus 13 times 4 squared minus 30 times 4 plus 8. Sure enough, that's 0. So the answer is yes. Now see how much faster that was. So that's why the remainder theorem is important. Let's do another one. Is x plus 3 a factor of this polynomial? So skipping the division, we don't have to do that. Let's just plug in 3 and see, do we get 0? And sorry, it's not 3, because to remember, it's the tricky thing about the remainder theorem. It's x minus a. So a here is not 3, it's negative 3, because it's x minus negative 3 is x plus 3. Okay, so we've got to remember to negate this number. So we want to find what's p of minus 3, which would be 2 of minus 3 cubed, plus 10 times minus 3 squared, plus 11 times minus 3 minus 6. Okay. Maybe to prevent from making a mistake, we'll do this a little bit at a time. Minus 3 cubed is minus 27 times 2 is minus 54. Minus 3 squared will be 9. 9 times 10 is 90. 11 times negative 3 is negative 33 minus 6. Okay. So minus 54 minus 33 minus 6 is minus 93, plus 90 is minus 3. So the answer is no. No, it's not a factor. And we know that because negative 3 is not 0. Okay, so that's how to use the remainder theorem to make those problems really fast instead of having to use polynomial long division. So now let's do one more problem that uses the remainder theorem. Given that p of x divided by x minus 3 has a remainder of 2, find p of 3. Well, if the remainder had been 0, we would know p of 3 was 0. But if we remember the remainder theorem, it says that p of x would equal the quotient q of x, which is this, times x minus 3, plus this constant p of 3. Okay, so p of 3 is what we want to know. So p of 3 would be what's left over when we divide p of x times x minus 3. This is just the polynomial p of x in quotient form. Well, we know what's left over because we're told it has a remainder of 2, so the answer is 2. Okay, so this is almost like a trick question. And this works because we have 3 and 3, if we were asked what was p of 7, we would have to know the polynomial to find that, and there's not enough information here to answer that question. But we can tell you what p of 3 is, because that is what we divided by. We divided by x minus 3, which would tell us that p of 3 is the remainder of that division. So we can go back to the remainder theorem and see that, okay, that this remainder p of a is, so that the constant we add is that is the remainder is p of a, where a is what we subtracted by to make this divisor that we used, and that's how we can use the remainder theorem to solve that kind of a question.